Okay, guys, here we go. Section 6.1. Welcome, and I'm happy to be with you today giving you a lecture on 6.1 slope fields. Sorry about yesterday. We had kind of an emergency with Amy having her appendix out late Sunday night around midnight, so made for a rough Monday. But I'm in here Monday night setting up for Tuesday because now I'm on for NHS today, which had been planned. So here we go. I am looking at discussing the three styles of AP questions that are usually found on the AP test. And so these are all going to revolve around slope fields. Kind of a fun topic, I think. So this, what we're looking at, is a slope field, and you can kind of guess that the slope field leads to circles. So if I followed those and traced it, it does turn out to be circles. The differential equation kind of picks up this format, y prime plus x equals 0. So this would be an indication of what my differential would look like if I subtracted x and then divide by y. Well, here's the differential equation, or you could say dy dx without the prime. Is equal to negative x over y, and indeed that is the differential for a circle equation. And right here you can see there's the original function, y squared plus x squared equals r squared, much like we know this to be a circle centered at 0, 0, because h and k are not showing up in our equation here. So kind of interesting. You will probably see ones like that in homework and on the test. Draw the slope field for differential equations. This is one style of test question, often in the free response question. This came from 2004, but very typical that they show a small slope field. Obviously, if you did too many points, it would be a lot of work, but I'm going to show you how to actually calculate out what the little tick marks will look like. So we're going to pick a point and find the corresponding slope, and then we'll go sketch it. So this is our differential function that we're given. Dy dx is equal to x to the fourth y minus 2. I think the best way to do this is to organize yourself in a table format. So I've produced that table that should be on your notes. I would go through that effort if I were doing the test myself. So what I'm going to do is look at all the possibilities, and this would be looking at like the ordered pair at x being negative 1, y equals 3. Well, when I put that into my function, what does it turn out to be? Well, it says that y prime, or the differential, the slope, would be negative 1 raised to the fourth, and then y minus 2, but my y value is 3, so I'd have 3 minus 2, and this would turn out to be, well, this guy's always positive, so that's positive 1. This looks like a slope of 1. So I'm going to erase this just so I can fit it on my chart a little better. This turns out with slope of 1. So if I go over to the location, negative 1, 3, we're talking about this point right up here, correct? So at that point, it has a slope of 1. So just kind of imagine if I went up 1 over 1, the general slope is going to look like that. So I kind of want to mimic that same slope parallel to that. So at this point, we've got a slope of 1. The thing I just noticed is whenever I put in negative 1 for x, this is always going to be a positive 1. So if I moved on to this next one, sorry, it should be negative 1 first, I'd have negative 1 comma 2. And when I put in negative 1, that's just going to turn out to be 1, isn't it? And then I'd have 2 minus 2 on this one. Well, that's going to turn out to be a 0. So when I'm at negative 1, 2, this location right up here, I get a 0 slope. And this is all we're doing, you guys. It's really not too complicated, is it? It's just kind of tedious. I know when I put in negative 1 for x, that's a positive 1, and now I need to do a 1 minus 2, but that's going to be negative 1. So the slope is negative 1 when I'm at this location of negative 1, positive 1, this guy right here. Well, what's a negative slope look like? Well, that would be like down 1 over to the right one, so it takes on this location, doesn't it? So I'm just going to kind of eyeball that, and that's the slope I'm going for. Boom. And it kind of all stays relative. I know this is a positive slope, 0 slope, and negative slope. And when they look at it for testing purposes, when they're grading it, they're looking for the same thing, kind of relative to each other. So we're at this point, negative 1, 0. And when I put in negative 1, I get out positive 1. And 0 minus 2 turns out to be negative 2. So I'm going to kind of use my guidelines here. This would be like down 2 over 1. So kind of this, a lot, well, not a lot, but in relative to the one that we just did, it's going to be a more steep slope because this one was -1, this one's now -2. We got one column done, 2 others to go. Now we're going to focus on when x is 0. This was when x was -1. When x is 0, I have 0, 3 as my location. This x to the 4th will always turn out to be 0, won't it? So I'll have 0 times some number. But 0 times any number is 0. So in fact, this is actually going to be a pretty fast column to go because all of these locations have an x value that is 0. So I'm not going to waste too much time and I'm just going to fill in zeros. Remember that x to the 4th was 0. So these are all just flat lines, aren't they? Horizontal slope gives us 0. Next, we're back to x being 1. But this will have some quickness to it too. So I'm at the location 1, 3. We're now focusing on this third to the right column here when x is 1. But if you notice, when I take 1, raise it to the 4th, it's also going to be positive, much like this was back here on this first column. So I believe we can kind of shortcut because 3 minus 2, and this would have been, what, 2 minus 2. The y values are identical, aren't they, to what we had done in the first column. Oops, that should be 0 minus 2. And then we had 1 times 1 times 1. These are identical slopes, 0, -1, -2, as what we had in the first column. So indeed, I can just copy those in. And that had a slope of 1, 0, -1, -2, slightly steeper. And we've just finished this. So if you wanted to, you could hit pause and go try and do problem 1 and 2 on the homework sheet. Or I'm going to keep going because I only have a certain amount of minutes to do this. We're at 7 right now. So, but the same thing here. What I would notice is that I've got x equal to 1, 2, 3, -3, x equals -2. What is that? X equals -2, x equals -1, 0, and so on. So if I were to build a chart on this, I would just throw in these x values and proceed with the various 2, 1, 0, -1, -2, 2, 1, 0, -1, -2 y values here. X is up here. And then you would, be able to do your chart really well. This will be an easy one. Notice that we have x equals 1. The y value doesn't make any difference, does it? So this really turns out to be -3 plus 1, but that's -2. Y value of 2 never entered into the equation. So this is going to be -3 plus 1 equals -2. I think you're going to find out that these vertical columns are identical the whole way down through the column. So I could fill in -2 there. When I'm at -2, I'm going to have -2 plus 1. My slope would be -1 here. And likewise, all the way down the column. When I put in -1, I'm going to get 0 slopes all the way down the column. So there's some interesting things. When I'm at -1, I've got 0 slope, don't I? Makes for easy slope fields when there's just one variable involved, and we're going to see a little bit more of that coming up. So you guys can hit pause if you want to do this now or continue on. You decide. On number 2 here, the thing that I noticed right away is there's my noticing. I noticed that this only has y values. So the y part of the coordinate pair is the player in this. It determines the slope. So I would bet you're going to find rows that have the same slope. When y is equal to 2, it'll be slopes that are 4. When y is equal to 1, slopes will be 2 times 1 or 2, and so on. So those will be quite easy. Okay, now if you would flip back, this is the a second type of AP question. Match the differential equation with the given slope. Of course, this would be in the multiple choice section. Elimination might be our best method, especially when working with these multiple choices, because you can make some very educated eliminations on the multiple choice. So first, let's just talk about what happens if I only see an x variable in the differential. For instance, I get those. I notice it's only x's involved. Based on what I was just showing you on number 1, it looks like if the x is involved, the columns are going to have the same slope. So on this one, what I'd like you to fill in is that columns will have the same slope. You're going to be able to look at this and say, ooh, if x's are involved and only x's, then I should see the same slope vertically up and down within that x value. And then if it only has a y value, like I see right here, the natural log of y, this one has x and y, and this one has x and y. So E has only y values. Well, then it's going to be rows that have the same y value. So jot those two down. And then we can talk about this particular problem, because you're going to find out it's pretty easy to eliminate some of these offerings. All right, back to our picture here. I noticed this thing, you know, it has positive slopes over here, but it isn't like this entire column has the same exact slope. Steep, a little less steep, a little less steep, a little less steep. Definitely left street. Oh, there's a 0. So this is not dependent on just an x value. You can definitely tell that. That means that I can come up here and eliminate which ones? Well, A was only on x's and B only had x's, so let's get them out of the running. Now let's look horizontally. Is there a pattern horizontally, meaning the rows pick up the exact same value, which would mean that this thing is a y-dependent slope? Well, no, because this had a 0 slope. This looks like, you know, maybe a half. This one, maybe 3/4, building to 1. The slopes are definitely increasing. So that means this thing with y only, the rows are not the same on our picture, so let's eliminate the y. That gets us down to C and D. At least we're on a 50-50, right? Big improvement over a 1 in 5 chance. Now, this is definitely an x plus y or x over y. It has both variables involved. How do I decide which? Well, the thing I like to come to next is just kind of analyze my quadrants, because here I can analyze what the overall positive negative will be of the slopes. If I have quadrant 1 where things are positive positive, well then on this particular one, my slope would look like positive x divided by positive y. I should see nothing but positive slopes. Quadrant 1, this does look like all positive slopes, so that's possible then. In quadrant 2, where the xy values are negative positive, I would have negative divided by positive. That would indicate then that all the slopes would be negative if D were my choice. Well, this just blows it right here, doesn't it? This has a slope of 0. This is a positive slope. This has negative. It's got everything going on. Let's eliminate that. C is our choice. If you did plug a few values in, I'm going to pick this one right here. Actually, I don't want that. I want to pick an x value at -1. Ooh, kind of. Let's say this is -1. That's hard to tell. 1, 2, 3, 4, 5. Let's go out at -2 because we know this is x equals -2. And then go up to 2, 2. If I put in -2 plus 2, I do get out 0. And you could randomly pick a couple other points and see that it works out, but C is our option there. Eliminating out ones that you definitely know it could not be. Third and final type of AP question, drawing the particular solution from the slope field. And we have done some of these in the past chapters, so you should be great at this. It's a graphical approach to solving the differential equations. Not all differential equations can be solved analytically, meaning we can actually take the derivative, use u sub or the power rule to solve an integration problem. So the best we can do is develop a slope field and draw the solutions. Get a shape going of what this must look like. So we want to come through, I'm going to come through this lower point first. So that's going to just kind of take my pen and just follow it along, I guess. Over here, it gets really interesting, doesn't it? It appears that we kind of almost hit an asymptotic behavior to some respects. Up here, it looks like, I don't know how well I'm doing on this, you guys. Something like that. I didn't quite hit it, but maybe even a little bit more gradual coming through there. But that is what they're expecting you to do. Just kind of go with the flow. That's the third and final AP questions that I've found varieties on. All right, so your homework for tonight is to finish these slope field drawings. You might want to use a chart like I suggested. So you get 1 through 6 on that. And then there's some multiple choice ones where you're matching up the pictures to the different functions. I believe it's a 1-to-1, that there's one picture for every one equation here. And then the same here, 4 pictures, 4 equations should be a 1-to-1 matchup. And a couple little things to do here. And then tomorrow we'll start back on day 2. If you are gone tomorrow, it's primarily free response questions. They're in your packets, so you could go ahead and finish it, because I know Lutz is going to be out, APUSH is going to be out hours 2 through 6. So that way you guys can come back on Thursday ready to go. Have a great day, guys.